Hi everybody, welcome to episode 5 on the Factory 400 channel. Today we're going to talk about a topic. This will be a talking episode. I'm probably going to put in some pictures and maybe something to support this a little bit. But I really wanted to kind of listen to some of the people that I was talking to. They're like, oh, make a great CNC video where you're shredding metal and all that kind of stuff, kind of the sizzle things, or electronics assembly or some sort of design thing or something that's a little bit more flashy. And I do want to get to that. I'm dying to get to that stuff, in fact, and I think it's fun and exciting. But really the only reason that I have a CNC machine and that I even know CNC machining and that I have all of this electronic stuff and I know how to make electronics, the only reason that is true is because I had to focus on the conceptual fundamentals of making a small business, and in particular making a manufacturing business. I'm not a business expert. I don't have an MBA or anything like that. However, over the past couple of decades, a little over 20 years, I have actually successfully designed, executed, built, and sold a couple of businesses, and done just fine. And it's fun and exciting. This is merely the latest iteration of what I'm doing. But all of that requires, one kind of universal thought, and that's minimum viable function. And that is a term. I'm not sure if anybody else uses this or not. I'm not claiming to have invented this, but it's kind of an extension of the concept minimum viable product, which is a term that I heard years ago in some of the startup books that I read. And the idea of a minimum viable product is if you want to launch a company or even launch just a product, you have to ask yourself, do you want to start off with an absolutely perfect product, or do you want to start off with one that you can actually build and get to the market? And most people, they would think to themselves, oh yeah, I want the perfect thing. I want it to be absolutely amazing before we release it. The problem is that perfection is the enemy of good, as some people might say, and that you might spend so much time, so many resources trying to make the thing perfect that you never get it released ever. Or let's say you get the thing released, you get your new product, your new whiz-bang, whatever, your new restaurant is open, whatever, and it's perfect. From your perspective, it's absolutely perfect. It's exactly what you wanted. And that's when you realize that after you've spent everything that you have, every dime and every hour that you have, you realize that nobody else thinks it's perfect. That for whatever reason, the market rejects you somehow, or it's not quite as exciting as you were hoping it to be. That is why startups have adopted the concept of minimum viable product, which essentially means that, like if I was going to make this this phone, I may start off with something, if my goal, I should say, is to make this phone, what I may do is start off with something more simple. I may start off with I don't even have an example, but start off with something simpler, because the reality is that I don't have the skills to design the phone. I don't have the manufacturing power to make the phone. It's going to take me years and years and years to come up with anything that's even the same as my phone. This one is a Samsung. It would take me forever just to make it equivalent. And by the time I came up with that, the market has moved on. It'd be old news, and nobody would really care. So I'd have to think of something simpler. And in my case, the first product was a box that deals with power on movie cameras. It's become kind of a complicated challenge to power up large movie cameras, full-size movie cameras. They have a lot of things and pieces and parts, and I had to, kind of think about that. Like, oh, I don't really know anything about it. I don't know anything about the problem. So I had to sit down and educate myself about every tiny little piece and part of the problem, exactly what I was going to solve. And once I got there, I had my wish list of issues that I wanted to solve. And I talked to a couple of people like, yeah, it'd be great if somebody could solve that problem. That'd be fantastic. And then it struck me that I have no idea how to solve that problem. I really don't. So I did some reading and was like, oh, cool. Now I think I know. And what I realized pretty quickly is that what I thought I knew wasn't even half the battle. It wasn't even a tiny fraction of the battle. What I learned over the next couple of months is that the problem to solve the problem is actually a really significant technical challenge. So I had to figure out what tools I needed and what skills I needed and all that kind of stuff. And ultimately, I put together a product that it was a fraction of what I dreamed it would be, but it was still something that solved a problem. So I kind of tried to get that thing out on the market. And just before the thing goes out on the market, it's got major malfunctions. It's got major problems. So I'm like, oh my God, I can't. I've already made huge concessions. I had my grand plan, my big, giant, I love this plan. I had to skinny that down 90% down to what I call the minimum viable product. And then I realized, like, I don't even have what it takes to make the minimum viable product, which means that I really have nothing. That brings us to here. We have a bit of a talk about the minimum viable function, and this was so critical for me to get where I am right now, and I wanted to share it with you because I don't think that this is much different for anybody else that's going to be getting into manufacturing, and probably a lot of other businesses. But from my perspective, it's all about manufacturing. So I decided to do a talking episode. I'm going to try to wing it as much as I can. I didn't want to script it, but I did make some notes, so you'll see my eyes going up. I'll be looking at some notes over here. So the first thing I should do is define what I mean by minimum, but I should define what I mean by minimum viable function. And essentially what I mean by that is, what functionality do you need as a person, as a company, to deliver your minimum viable product? You have to be able to deliver something. It has to be at least the minimum that the market will accept, preferably better, but you can't go below the minimum, because the minimum kind of says nobody's going to buy it if it's less than that. So, what is that going to be, and what does that include? So let's see. Let's take an example. You just bought some software, and you kind of look at the specs of the software, and it says the minimum computer requirement is, this kind of processor, this much memory, whatever. And it's like a computer has to have a monitor. That's an absolute minimum. You have to have a keyboard and a mouse and all that kind of stuff. There might be a limitation on the operating systems that your software can choose or can operate on. So if you have the software, that's great, but you don't have the computer that is capable of running it, the software becomes useless and you don't do anything at all. You're at zero. Another example of a minimum viable function is a car. So if you think about the minimum function of a car, it's supposed to get you relatively safely, we hope, from one point to another. So, when you're talking in terms of minimums, you're not talking about Porsche. You're talking about something basic. So, the car, it has to have some sort of a chassis with wheels attached to it. You have to have a steering mechanism, a seat, an engine, some kind of propulsion system, whatever. The minimum pieces and parts that allow it to get you from point A to point B. And in most countries, of course, there's legal things that has to meet certain safety minimums and all that kind of stuff. But if it has roll down windows, you're still going to get to where you're going. If it doesn't have air conditioning, you're still going to get where you're going. If it doesn't have leather, you still get to where you're going. No big deal. Anyway, another one, those are hardware minimums. The next one is skill minimums, and this is a big one. Hardware minimums tend to be very obvious. Skill minimums are a little bit more nebulous, a little bit harder to put your finger on. So in my case, I was trying to build this little this power box, but I'd never done power electronics before. In fact, in electronics, I'd really only done hobby level electronics and maintenance, and I could desolder stuff off of a board, but I would only know to desolder it and replace it if it was like burned to a crisp and I could visually see, oh yeah, that thing is definitely burned up. I'm going to replace it with another one. I had to, develop some sort of engineering skills. And engineering is a super broad topic. So which ones do I need? Well, of course, electrical engineering skills. Well, even electrical engineering is far too broad. You can't just go out and download to your brain an electrical engineering degree. And even if I had an electrical engineering degree, there are dozens of specialties of electrical engineering. So no matter what, I was having to learn something. And in my case, I don't have an electrical engineering degree, and my skills were pretty limited. I had a digital multimeter and a soldering iron, and that was it. So clearly, I had to learn some skills. And what I learned pretty quickly is that I've got this problem, and what I was learning is that it wasn't a problem. It was actually a whole bunch of problems that could be broken up into smaller chunks. Now, this realization was critical and important. I had to learn about MOSFETs, transistors. I had to learn about control electronics. I had to learn about PCB design. I had to learn about all these different things. All of those are different pursuits and different lessons to work on, and I had to learn all of those things all by themselves. I had to learn how to test things. I realized that you can't design electronics with just a multimeter. That's too crude of an instrument. I needed an oscilloscope, and I knew conceptually what an oscilloscope did, and I had one when I was younger, in fact, but I didn't really understand the tool and exactly how to use it and what its strengths and weaknesses and limitations were and what all the accessories were for and all those kinds of things. So even when I'm like, I need an oscilloscope, so I bought one, and then I had the learning curve of learning how to use that instrument. And then I had the learning curve of learning that I didn't know how to use the instrument. I thought I knew how to use it, but I didn't really know how to use it, and had to go through that whole thing. So I had a minimum set of skills that I was kind of going after to make this happen. So why in the world is any of this important? Why would I choose to make a video about this? It's mainly because as a manufacturer, you have limited resources. So you have to kind of think in terms of minimums because you only have so much time and you only have so much money, and those are the two most important resources that you have. If you go above the minimums, you can kind of classify that as waste in some respects. If you fiddle around with too many details, you will waste time. If you don't have the right skills and you're just hacking your way through a job, you might go through 10 prototypes instead of 2, which means that you're wasting both time and money, and the end result is that you don't get anything done. So essentially, if you're going to make a widget of any sort, you have to make it for a lower cost than you sell it. And the more time that you spend on the development and the more money that you put into the development, the harder it is to make the cost lower than what you can sell it for. So essentially, if you don't have the ability to function at the appropriate level to make your product, clearly you don't have a business. And that can be a limitation in your tools, manufacturing stuff, equipment, whatever that might be. And it might be a limitation of your skills, like you just don't know how to do it. So talking about the minimum function in terms of the skills that you have, or maybe more importantly that you don't have, you have to think about where you're going to get those skills. And some people go from the top down. And what I mean by that is college. You go into college or some sort of higher education, whatever that may be, and you learn a whole bunch of stuff preemptively before you even know that you need to know it. You might take business classes or engineering classes or whatever. You take the business class before you start the business. You take the engineering classes before you go out into some engineering endeavor. The other way, and this was one that I was kind of intrigued by a talk that the Amp Hour host, what's his name, Chris Gamble, the guy with he does the Amp Hour with Dave Jones, a great podcast. I love it. But one of the talks that he gave at one of the Hackaday conferences was about bottom-up education, and it sounds like that's kind of the direction that he went. It's definitely the way that I went. Like, for example, when I got my my first CNC milling machine back in 2006, about the most I could do is spell CNC. That was it. I didn't know anything about the machine really, at least not how to operate it. All I knew was that I had some examples of parts that came out of a milling machine, and I knew that those parts were very similar to what I was hoping to make. So I was pretty positive that the milling machine could make the parts that the kind of the reference parts that I had in my hand. Had no idea how to do it. So I bought the machine and I just dove in. I found books. I started pushing the buttons. I started asking people. I bought some software from a company, and I kind of asked the guy that came to set up the software for me. It's like, hey, can you work on the weekends? And I gave him a little bit of money, and he kind of helped me get the machine up and running and kind of understand some of the fundamentals. And then I just started going for it, and I made all kinds of mistakes and broke pieces and parts and all that kind of stuff. But eventually, I got pretty good at it. So that's bottom up education. I just figured it out, and it's not because I'm exceptionally smart. It's that I was tenacious enough to go dig for the answers and then dig for more answers. And generally one answer leads to another question, and then I have to answer that question. It just kind of goes on and on and on. So as long as you've got the energy to go after the problems, you can learn. I don't think I've met very many people that truly have learning disabilities. There's some people that learn in different ways. There's some people that learn faster and slower. But really, the smartest people, the most functional people that I know are the ones that they just go after it. That's it. They don't feel like a limitation is a limitation. They just feel like a limitation is just a speed bump in the road, and somehow, some way they're going to get over it, get around it, something. Me personally, it doesn't matter if you go to college or you decide to self-educate. You have to pick at least one of those things. But I think in real life, especially after hiring a number of college graduates over the years, college doesn't make you smart. College gets you a piece of paper. It gets you, some credibility, some qualifications, but you still have to educate yourself on a daily basis, regardless of where you go. If you go into finance, or you go into engineering, or you're a doctor, or anything that you went to college for, you don't stop learning when you graduate from college. You still have to learn how to educate yourself, and that is a critical thing to kind of maintain a minimum level of functionality, a minimum level of effectiveness as the world continues to modernize and to get smarter than you are. Skills, a lot of people think that's purely an education thing, a formal education thing, but skills are that they come from your life experiences. They come from making mistakes, I think, is an important way that you gain skills. I've broken a lot of things and failed on a whole bunch of things. But those are, as a lot of people will say, those are opportunities to learn. And I certainly learn from them. I don't let a single mistake get by without figuring it out. Usually for me, if I've got something in front of me that's not working, everything stops until I figure that out, because it's not so much that I want the thing to work, it's that I want to understand why it didn't work before. Like, what was it that I was missing? Why did I overlook something? Why was I not able to figure something out? That is a critical skill, and you don't learn that from school, and you don't learn that from a book. You teach yourself. You are your best teacher, trying to get that skill level up to what is ultimately going to contribute to your minimum viable functionality for your company, for your endeavor. Okay, so the next the next thing we should probably talk about is you have to have a minimum level of skills, as we discussed, but the minimum level of equipment is important too. Like I was talking about with my power box, I had a soldering iron and a multimeter. Great, those are two excellent tools, but they're not going to get my project done. My project required all kinds of power electronics that are switching and monitoring and all that other kind of stuff. Just not going to get there. And it was a situation where I couldn't rely on luck either. So I knew I had to get something else. That was going to be an oscilloscope. Was the first major thing that I got. But I had to first understand that was a limitation, and then try to figure out which one, which oscilloscope what was the absolute minimum, because if you look at oscilloscopes, they can go up to $1 million. So I got the cheapest one. I got this horrible, terrible 2-channel, 100 megahertz Regal, but it was enough to get the job done. It was only a few $100s. I knew that I was going to outgrow it really, really fast, but it got that project done. I was able to sell 20 or 30 units, and then I went on eBay. And eBay has turned out to be kind of the minimum viable function dreamland, really, for a small business, because I only have so much cash. But my needs were rapidly increasing. So I needed a much nicer oscilloscope. I needed power supplies. I needed test cables. I needed preamplifiers, current probes, all kinds of stuff to design the next level of stuff. And you go get a quote from the major manufacturers, and you're looking at 6 figures in a heartbeat. So it just wasn't an option. So I just dug around eBay and to see what was available. As I would find something that was available, then I would kind of peel off and start doing the research, what that thing was, when it was made, how likely is it to break, how hard is it to fix, what function does it have, does it solve my problem? I mean, asking a pile of questions, because for the most part, keep in mind, I'm buying stuff that I don't really know much about the equipment. It's kind of like the CNC mill I mentioned earlier. I knew I needed it, but I didn't really know much about it. I didn't know how it worked, or what its limitations were, or what other accessories I might need with it. So this blows up into a huge research challenge that I'm constantly reading things and asking people. The EEV blog was an amazing resource during this time. It still is today, but it was an amazing resource while I was trying to figure out what the heck do I need to pull this off. Critical questions. But once I figured it out, you could find a scope on eBay for $750 that solves a problem that the more modern version of it might be $7,500. So I could kind of pull this off, and kind of shuffling credit cards to kind of make these things happen. Again, I get a new piece of equipment. That piece of equipment, every equipment purchase that I've made, like whether it was a screwdriver or an oscilloscope or anything else, it was directly related to a sale that I was going to make in the near future. So the only stuff that I would buy is something that would financially justify itself within a month or two, because that's about how long I had to flip the credit terms that I had, whether a credit card or PayPal or kind of whatever. And the only way I could keep it going is to do that. I didn't have the option of getting a loan and just buying a whole bunch of stuff. Enough about eBay. Moving on. Should probably wrap it up here. This is kind of getting long. I have no idea how long it is, but anyway, the important thing is to not lose sight of what your minimum viable function should be. It should match what you plan to deliver. If you have more functionality than what you're delivering, it's wasteful. Like if you have a factory that's capable of building 10,000 cars, and what you're delivering is an iPhone case, that's not efficient. So you can kind of break that down into a less dramatic example in your own mind, but your minimum function should only be slightly more than what you plan to deliver. This is pretty critical, especially for us if you're a small outfit like what we're talking about in the context of the Factory 400. It's really all about time and money efficiency. So another thing to keep in mind is that the MVF is a moving target. This is not a goal or a place that you arrive at. It's something that you're kind of going after, and you're always redefining it and rethinking about what is my minimum viable function today. And I can tell you that rewind the clock back a few years with me, my minimum viable function was basic understanding of electronics, a digital multimeter, and a soldering iron. That was it. That's all I really needed. And then all of a sudden I needed extra equipment. I needed an oscilloscope. Well, the oscilloscope led to another thing that I needed, was the skills to understand how to use the oscilloscope and how to interpret it. Well, okay, fine. I learned how to do that. Well, then that led me into circuit analysis and the more of the electrical engineering part. And the more I learned about electrical engineering, the more I realized that the scope that I had was kind of inappropriate for what I was trying to do. So I had to get another scope. And this kind of is, you can see how it's constantly moving to where, today, I've got a huge amount of equipment, but every single piece, every single part, if we were able to go through every single thing that's here in this room, it all has a function and a reason for being here. I don't have anything extra. I don't have anything superfluous. There's nothing here because I just think it's cool or anything like that. It's all related to being able to deliver the pieces and parts that I deliver. Really critical to keep that in mind. If your actual functionality is less than your minimum viable functionality, you lose. If your actual functionality is significantly more than your minimum viable functionality, you also risk losing. And on one of those is kind of obvious. If you can't do it, you're going to lose. The other one, it's like, well, yeah, if I have all this extra stuff, why is that going to hurt? It hurts because you've wasted money and you've probably wasted time learning it, and it kind of becomes a distraction. So it becomes a risk. It doesn't guarantee that you lose, but you risk the whole. You kind of miss the big picture by wasting your time with shiny objects, fancy tools, big learning curves, lack of cash because you spent it on some other thing. Let's take an example. I really wanted to get Altium Designer which is a really high-end PCB layout software, but it cost $10,000. At the end of the day, I decided, you know what, I can make do with Eagle, which at the time I think I spent like $700 or $800 on it or whatever for the version that I got, and I didn't like it from the beginning. I don't like it now. I think it's a weak piece of software, but I was able to get stuff done, and I've continued to be able to get stuff done for years, and I had an additional $9,000 and whatever dollars to spend on other things that were even more important. So what I gave up getting the lesser software is less of a problem than the cash that I would have had to give up to get the nicer stuff. So balancing minimum viable function. So take some time to consider what you do and what minimum viable functionality you have to have in terms of skills and in terms of equipment to be able to deliver whatever it is that you want to deliver, and then analyze yourself and say, do I actually have the skills? Do I actually have the equipment to do all that kind of stuff? And if you don't, you have to change what you're going to deliver to match what you can actually do so that you can deliver something that you get paid for, and then you can just slowly kind of build up to what you actually want to do. And that's exactly what I've done, and that's it. So I hope that some of this stuff made sense. I hope that it stimulates some conversation, and I really hope to get to the metal shredding episodes where we're off on the milling machine or something that's a little bit more exciting. But I think it's important to think about these the critical concepts that drive every single day and every single thing that I do, and you'll understand as you see me going through these various processes and struggles. It's not just for fun. Although it is fun, it's not solely designed for fun. I didn't get all these pieces because they're cool and shiny and just exciting. I got them because I want to deliver a product that I can sell, that I can make a profit on, that I can make a business out of, and I can move on and onwards and upwards. So hope you liked it, and I hope you leave some comments. I hope this stimulates some conversation, and we'll see you next time.